Across India, thousands of crores are spent every year on water projects. Yet many of these systems fail long before their expected life. Pipelines burst, reservoirs run dry, groundwater turns toxic, and entire cities depend on tanker water. Today, we are going deep into the top 5 water bus failures in India. What caused them, what engineers learned, and how you can prevent them on your next project. Stay until the end for a free downloadable grid checklist that will help you to eliminate 70% of preventable failures. Every failure you will see today is real people, real engineering decisions, real consequences, and the same mistakes repeat again and again from small panchayat to mega city. So this video is not just information, it's a survival guide for engineers, consultants, contractors, operators, and even administrators. Alright, let's begin. Let's start in Chennai, 2019. You may remember the headlines. City faces day zero. 4 major reservoirs bone dry. People lined up for hours near tanker stations. Hotels shut down kitchens. IT offices reduced working days. But here is the truth. This was not only a rainfall crisis, it was a structural and planning crisis. What went wrong? Dependence on only a few mega reservoirs? Loss of thousands of rainwater ranges that earlier supplied the city? Encroachment of catchment areas? Delayed maintenance? Over-extraction of groundwater? The engineering lesson: a system fails where it has no redundancy and no recharge. Prevention strategy: revive local ponds and temple tanks. Create distributed storage networks, not single point dependence. Mandate rooftop rainwater harvesting enforcement. Use demand management, pressure control, tariffs, leak prediction. Protect catchments from real estate encroachment. Diversify supply, discharge always. Don't wait for the reservoir to run dry. Now shift to Delhi, a city with one of the largest water distribution systems in India. Yet, non-revenue water is massive. Pipes are decades old. Many sections still run on intermittent supply, and that's where the contamination starts. Because every time pressure drops, sewage from outside enters through the cracks and joints. Residents often report foul smell, light brown water, or suddenly turbidity spikes. Let's see its 4 causes. First, old pipelines made of GI or corrugated steel. Second, unchecked illegal connections. Third, pressure drops due to intermittent supply. Fourth, no district metered areas. Fifth, limited preventive maintenance. We can see many cases in sites like this. In several Delhi colonies, samples repeatedly failed bacteriological tests right after supply resumed. Classic sign of negative pressure suction. We can improve the supply hacks with adopting these prevention strategies. First, upgrade 24/7 continuous pressurized supply. Second, replace vulnerable mains with HDP or DI. Third, deploy DMAs with smart meter. Fourth, GIS maps all pipelines and valves. Fifth, strict cross connections enforcement. Sixth, maintain chlorine residual uniformly. And always remember, pressure plus good pipes equals safe drinking water. Let's move east. West Bengal, Bihar, Assam. Here, millions depend on shallow tube wells. But over the last few decades, arsenic contamination emerged as a silent killer. Chronic exposure leads to skin lesions, black spots, and even internal organ damage. In Western India, the parallel story is fluoride contamination, causing bone deformities in children. Why did this happen? First, wells were drilled without chemical testing. Second, no screening or sanitary seals. Third, people kept switching from surface water to groundwater. Fourth, no long-term monitoring of arsenic behavior. Fifth, lack of community awareness. Test the field inside. A single village having 40 hand pumps may have arsenic safe water in 3 pumps and unsafe water in remaining 37 just because of geological layering. So now we go to prevention strategy. First, always perform field drilling, water quality test. Use deep aquifers only after expert hydrological verification. Third, install community water treatment units. 4. Continuous monitoring through PhD lab. 5. Park safe and unsafe well clearly. 6. Raise public awareness on symptoms and risks. And always keep in mind that never pump what you have not tested. In Bengaluru, a single pipeline burst can waste lakhs of liters and flood entire stretch of road. Why so frequent? Because network is old, the terrain is hilly, and pressure fluctuations are extreme. In many cases, the pipeline failure is not due to material failure, but pressure management failure. Let's see some root causes here. First, uneven pressure zones. Second, road cutting by multiple agencies. Third, aging pipelines. 4. No predictive maintenance. 5. Lack of valve control maps. Now we go to a case example. A DI main burst after a new apartment building connected illegally and shifted loads on the pipeline bedding. In another case, contractors digging for optical fiber damaged a major water main because no accurate GIS map existed. Therefore, we are to go for its prevention strategy. First, routine pipe condition assessment. Second, road cutting coordination across departments. Third, replace high-risk pipelines on priority. 4. Install pressure reducing valve (PRVs). 5. Community leak report app. 6. Emergency repair teams with response target. Key message we borne in mind always. Fix leaks when they whisper, not when they scream. Finally, the rural and coastal crisis. Gujarat, Tamil Nadu, Andhra Pradesh, Odisha. When groundwater is overpumped, freshwater pressure drops and saltwater enters the aquifer. Farmers notice it first. Their pumps gives more water, but it becomes salty. Then borewells start collapsing or yielding very low discharge. Key causes we noticed about these are: first, no pumping regulations. Second, poor borewell design. Third, no gravel pack or sanitary sealing. 4. Over dependence on groundwater. 5th, zero artificial recharge structure. Here we look field restoration. In parts of coastal Tamil Nadu, entire villages abandoned old borewells because saltwater intrusion reached 7 to 10 kilometers in length. So now we can take these prevention strategies. First, pumping permits and monitoring. Second, proper well design, casing, screen, gravel pack. Third, mandatory recharge wells and percolation ponds. 4. Reduced pumping during summer. 5th, promote treated surface water over groundwater. Final message, we do remember, pump less, recharge more, protect your aquifer. Here is your WATERWORKS 360 prevention checklist. It has been divided into 5 parts. Use it during planning, tendering and field inspections. Part 1, it is about pre-project, in which first, hydrogeologic survey. Second, soil sustainability check. Third, water quality testing. 4th, risk register. 5th, community consultation. And in second part, it is about design, in which first, redundancy in storage. Second, pressure zoning. Third, certified pipe materials. 4th, sampling points. 5th, cross connection separation. And in part 3, it is about construction, in which first, quality insurance or with quality control testing. Second, GPS map pipelines. Third, certified drilling teams. 4th, sanitary borewell drilling. 5th, daily site inspection logs. In part 4, it is about operations, in which first, GIS asset register. Second, quarterly pressure or leak audit. Third, routine water quality reports. Fourth, preventive maintenance calendar. Fifth, 24 into 7 grievance system. In part 5, emergency response, in which first, spare parts inventory, second, alternative water source plan, third, public alert and boil water notice protocol, fourth, post-incidental audit. It's all about the water prevention checklist you see here. Water failures are not destiny. They are engineering problems with engineering solutions. If you are an engineer, take this checklist to your next project site. If you are a citizen, demand proper testing and leak control in your city. Download the free PDF below, like and subscribe, and comment your city name. I will make a dedicated how to fix it breakdown for your area. Together, let's build WATERWORKS that work for India.